Hello everyone. So this is the first video in this series of mathematical physics. So based on suggestions I received, I changed some of the ways I am presenting, which you will be seeing. So in this first video, we'll be looking at some basic functions which are used in physics. So as you know, in any physics problem, using principles and equations, we convert this problem into a differential equation. And we solve the model and we end up getting a function. So everything about the problem can be understood if we look at the function and plot it. So plotting is a very important aspect in understanding any problem of physics. So what is the equation? So generally it comes as a solution of a differential equation, or otherwise it contains something like this. So y is a dependent parameter which depends on a parameter x. So I'll be referring x as independent parameter and y as dependent parameter. Now this x and y has a dual usage. When we plot, we say x-axis and y-axis. So x-axis and y-axis I use in the context of plot, as well as xy as a spatial coordinate. So depending on the context, it can be understood. So apart from x and y, there are other things which are denoted by a or beta or c or sigma. Now, what is the importance of these parameters? So it is very important to understand how these parameters affect the graph, or looking at the graph, deduce these parameters. Particularly important when we have two graphs of same equation but of different parameter. So how to decide which equation corresponds to which parameter? So to start with, let us take the simplest function, that is a straight line. So now this is another paradigm of learning where any aspect which we want to understand, it is easy to grasp, understand, and remember over a period of time if you convert information into tables. Now this is not a complete representation. This is what I look at it. You can make your own table. For example, I'm starting graphs. So now one of the graphs column is straight line. So how does the equation look? So most familiar equation is mx plus c. So then we can ask what are the values x can take. So we can have a separate column for x. X can take values from minus infinity to plus infinity. Y is equal to mx plus c. So what are the permitted values of y? What values it can take? So that also can come as a column. So most importantly, there are two symbols, m and c. So m is referred to as a slope and c is referred to as intercept. Now what values these parameters can take? That also we can keep. So if you're in BSc first year, you can make such table, and as you go along second year, third year, MSc first year and MSc second year, by the end of your MSc, you will see that there are not many functions to deal with. It's not infinite, it's only limited number of functions which we are dealing. And if everything is together, then we get a overall perspective of a subject as well as concept. So let us now move to visualization of these things. So here I have this panel. So there are parameters. So the parameters are represented as A, B, C, D. So in this simulation, D will not be used. Anyway, it is there, but we will not use it. So A, B, C will be using. We can change those parameters and we can select a function from here. There are different functions. This is not complete list. This is some of them. So if you want to include any of the functions, please leave a comment and I'll try to include in that. Now, once the function is selected, how the plot looks. And the second is, now what is the influence of each parameter on the function? Now, those parameters can be selected from here. Function is selected, the parameter is selected. Now to change the parameter, there's a slider. This slider changes the value of the parameter selected for the selected function. So we can see how the parameter affects. So first let us see for a straight line. So let us give some parameter per a. C is not required for this. D is also not required for this. So the initial parameters are printed here. A is 1.2, 0.26, B is 0.42, and then let us plot this. So with this parameters 1.26 and 0.42, the plot looks like this. Now let us change the parameter A. So the parameter A can take values from 1.2 to 6.28. Let us increase the parameter and see what happens. So this will be x-axis. It is not marked, but this is x-axis and this is y-axis. So 1.26. Now let us do it. 2.8. The graph appears to shift parallel to the original thing. So let us see what happens when we compare two graphs. Let us compare this. So this graph is for 2.86. Now let us increase this parameter. This is 4.5. This is 6.3. Now this is 1.26 and this is 0. Now most important, if this parameter A is 0, the line will pass through the origin. Let us see where is that 3.25. Now 3.25, as I saw given a name in the first slide, is known as intercept. So when x is equal to 0, what is the value of y? So this is intercept. Now let us look at the parameter b now. So to start with, b is 0.42. Okay, so let us look at b. 0.96, 1.5, 2.06. As you can see, the intercept is remaining same, but the angle is changing. So let us superimpose and see. For different parameter of b, and when b is 0, it is slope is 0, so line parallel to x-axis. As you can see, for different parameters of b, the a remains fixed, that is the intercept is same, but the angle has changed. So that angle is referred to as slope. Let us see what that means. Again, initiate it. Okay, this is the line. So let us see the meaning of b. Yeah, somewhere here it will be easy to visualize. So b is 0.5. So it is referred to as slope, that is y2 minus y1 by x2 minus x1. Look at this here. It is 4 and here it is 3. So it is 4 minus 3 is 1. And then over a distance of 2, that is, it has changed by 1. So 1 by 2 is 0.5. So to summarize, A represents intercept, which is this value. At x equal to 0, what is the y value? And B represents the slope. So how fast it is going away from the x-axis. So it is important to note, as x is changing, what is remaining constant? The slope is remaining constant. When we look at the graphs, the first point is at x equal to 0, what is the y value? Second point, important point to look at is, as x changes, is there anything which is constant? In this case, it is the slope. That is y2 y minus y1 by x2 minus x1, it is constant. So let us look at where this function comes in physics. Well, this is it is difficult to answer a comprehensive thing where in physics it comes. Everywhere it is there. So I have tried to tabulate some of them. So all the way from Newton's laws, where it comes, Newton's laws in mechanics, the equations looks like F is equal to ma. So the y represents this, y represents force, and x is acceleration. So the slope, the intercept, the slope constant is the mass. In Hooke's law, F is equal to minus kx. So the y-axis is force, x-axis is extension, and the constant is spring constant. So there are many things, one-dimensional motion. So you can pause it and check. So this is not a exhaustive or complete list, or you can add columns if you want. This is an individual choice. So another important thing is instrument. Now, this is a famous equation which we come across. Temperature in Fahrenheit is equal to 32 plus 9 by 5. temperature in degree centigrade. Now this is how instruments are made. It's a calibration. Both intercept as well as the slope are related to calibration process. Also, there are experiments where straight lines are used to calculate fundamental constants. Many of the experiments in undergraduate we come across. For simplest example is simple pendulum. The graph between t square, L and t square, which gives a straight line. From that, we can calculate the value of G. So straight line is very, very important. And this is not the complete list. Please write to me. I will email you this list if you want, or if you make your own list by adding many more things, please let me know. I'll be happy to add them here. So let us look at another function. So let us look at another function, cosine. The cosine function was uh, extensively dealt in one of my earlier videos. You can check that video. Here I'll give you a very brief presentation. So let us put A as 2.35, B as 1, and C is equal to 0.2. And let's generate. Yeah, so this is the cosine function. So, but here, very quickly, let us look at the special points. Now, where is this? 4.085. 4.085 is the height. It is referred to, it will be referred to as amplitude. B is 1. That means this B is 1. So in 2 pi of x-axis, how many oscillations? There is one oscillation. And phi, this is 0.2, where this function is starting. So one thing which is not there in that video is overlap. So let us see the overlap here. So when we overlap with, now let us compare graphs with a different parameter of A. This is with 1.13. This is 2.8. This is with 4.6, and so on. Let us take the parameter B. So B is 1 at present. .8. Now you can see things will change, but the parameter here, what is the y value? This remains same. Everything else appears to change, but this point remains constant. So let us look at parameter C. Okay, let us little bit decrease this to appreciate it better. Let us change C. You can see it is coming here as C is increased. So let us look at the PPT now. So the cosine function, the most general form looks like this: A cos omega t plus phi. So A is referred to as amplitude, omega is referred as frequency, and phi is the initial phase. Now t can go from minus infinity to plus infinity, but when you look at problems, you should be careful. Though the function can go from minus infinity to plus infinity, in the given problem, does it so? Does it go from minus infinity to plus infinity? Otherwise, what is the implication? Now, this function comes in also wherever there is a periodic thing or wherever there is a vector, this comes into picture. In mechanics, generally we will see there are deals with vectors, force vector, velocity vector, F cos theta, or problems involving slopes, oscillations, A cos omega t plus phi, waves A cos kx plus minus omega t plus phi, whether both space and time parameters are coming. In electronics, we always see a sinusoidal voltage, V is equal to V0 cos omega t plus phi, and cos is used in Fourier series, both cos and sine. Interference of waves, I1 plus I2 plus cos delta. Important thing to note here is in this there is a I1 plus I2. This is like a DC term. which is not there here. So this is like some d plus a cos omega t plus phi. So there are many things: birefringence, nonlinear optics, ray tracing, and there'll be many more. And this table representation is very useful. Now we are covering from mechanics first semester, second semester, and electronics fourth semester, and optics fifth semester, nonlinear optics sixth, seventh semester. As you can see, these functions will be used throughout. So if you understand once, this understanding the subjects becomes very easy. Also, you can use, because we are making it on a computer, we can use this table more visual. I have added colors, for example, here. So here, when we deal f cos theta t, this theta remains constant for a given problem actually. So that I have put in red, those kind of things. But when I say oscillations or waves, the overall phase which sits in the brackets changes. So you can put any other color scheme. You can add which semester or which page number, which website. You can keep on adding columns. This way, it becomes very easy to understand physics. So keep watching for more videos on mathematical physics. One important thing is, since mathematical physics cuts across all semesters, there'll be no particular sequence of videos.